How are we doing, everybody? Welcome to another edition of Math with Mr. Stevens. Today we're going to be continuing in Module 4, continuing in Lesson 15. And in this particular case, we are in the Lesson 15 problem set, which is on page 175. We're going to be taking a look at a few more a little bit later, or a few more at the end of this problem set. Okay, we looked at the first couple, or a couple at the very beginning of the problem set here in a previous video. And so here we're just going to be looking at numbers 10, numbers 13, and number 16. Okay, so looking at 3 problems here. You'll have some of these that are just assigned to you as well as part of your Google Classroom. So, taking a look on page 175, that's where you should be. So, we're looking at question number 10. Again, as always, we're looking for the slope of this non-vertical line. We know it's not vertical, obviously. But we're looking to get from P to R, and that's always our case. We're looking to get from one point to the next. In particular, though, and we're going to see this next lesson in lesson 16, is that we can use any set of points to determine our slope. We could use this point here, let's call that point T, just because. We could go from R to T. We could go down here, and we can call this, let's call that S. We can go from T to S to find our slope. We could go from P to S. We can go from R to S. We can use any of these sets of points to find our slope. Alright, so when we go from P to R, we're going, remember we always go up or down first. Okay, so to get from P to R, we have to go down 2. We have to make sure we use the correct volume, so we're going from 4 to 2, so we're going down 2. And then we're going 1 to the right, so it's a positive 1. So when it comes time to create our slope, we have to look at our change in y. Our change in y was a negative 2, divided by our change in x, which is a positive 1. That gives us our slope. So our slope is negative 2 over 1 is just negative 2. Pretty straightforward. Turn the page. Question number 13. Again, same deal. This one is more like question number 4 that we saw in the previous video, where we have rational numbers here as part of our coordinate plane. Again, a coordinate plane is made up of 2 number lines, so all numbers, both rational and irrational, are somewhere on this number line. Not all of them, though, are shown. Here, they show in half-unit increments for each grid. Okay, so here's our origin all the way up here, and here's our line. Per usual, we're going from P to R. We should be able to see as we're going from left to right, we're moving up. That we're going to have a positive slope this time. So we're going to increase. Our slope is going to go up. And so we're going to go up 1, 2, 3. 3 of these, which would in turn be 1.5 actual units. So it's a plus 1.5. And then we're going to go 1 to the right. Okay. So that, and we go 1 because this is a half and this is a half, so it's a plus 1 to the right. So our slope is, we have to look at our change in y divided by our change in x. Our change in y is a plus 1.5. Our change in x is a plus 1. That gives us our m. That gives us our slope. And so our slope is 1.5 as value. Simple as that. That's it. That's all we're looking to do for right now. Soon, we'll be taking a look at these lines and seeing, okay, so what is the slope? And then very, very soon, we're going to be looking in particular at this point right here. Okay, this is your point. Here's your y-axis. Okay, this point in particular, where it crosses your y-axis, is going to be very, very helpful to us here in the future. Okay, but for right now, that's just kind of a look ahead. For right now, we're just looking to be able to find the slope on a consistent basis of any line that's given to us. We also need to be able to find the slope of equations and lines that, even if they are given to us, don't always have nice ones. So taking a look at 16, this does not have a very nice slope. Okay, sure, we've got a nice incline. We know it's going to be a positive value. But when we take a look at some of the places where these points are, they do not meet at whole values. Sure, their x values are whole, but all of their y values are not. And that's a bummer. So what we can do instead is we can use the other pieces of information that we have. There are 2 other ways aside from using a graph to find the slope of a line, to find the slope of this situation. This is an old situation. This is from something back in, I think, like lesson 11. So they're using this now, taking a look at this in terms of its line, finding the slope of its line. Okay. So what is the unit rate? They ask how much in 1 minute can she paint, or really what's the unit rate? And so in 1 minute, we should be able to easily look at the table here and determine that she can do 6.4 feet, or yeah, square feet. So for part A, it's 6.4 square feet. We can use our table, and we should use our table when we're given one, to answer that question. It's very easy. When we look for 1 minute, boom, right there, 6.4 feet. We can also use our graph though. If we go to x as being 1, we know that time is often our x value, and we go up to where our line is and eventually see where it meets our line, we know that it's a little bit above 6. We don't know its exact value though. Unfortunately for us, this does not meet out a whole value, so it's going to be tough for us to figure out what exactly that value is, which means we're definitely going to have to use this table and even this equation. Okay? So for part A, her unit rate, which is essentially in 1 unit of x, what does y equal? In this particular case, it's 6.4 for A. Then for part B, assume that the graph in the situation is a line. What is the slope of the line? Now they're asking you to do what we've been doing, which is to find a slope between 2 points. The problem with that is when we're going from here to here, we don't have these clear grid lines to move along. But like I said before, when we have a table and when we have an equation given to us, we should use that. In our equation and in our table, we are given the equation. It's right here. A equals 32 over 5t. Guess what? That 32 over 5, that's what our slope is. That's our constant of proportionality. That's our unit rate. It's all the same value. It's all the same thing. It just has a different name and a different context sometimes. So when they're asking for this slope, they're asking for when x changes by a certain amount, when x changes by 1, how much does y change by? Well, it changes by 6.4. We can do that by looking at our equation. This value right here, that coefficient of t, is always going to be your slope. Okay? You'll also see it as the coefficient of x. That's going to be your slope as well when you have a more traditional slope-intercept equation. Okay? There's one other way to figure this out though, beyond just looking at the equation and beyond trying to use the line that is given to you on the coordinate plane. There's also using the table itself. Tables are extremely useful. When we go from 0 to 1, what happens to our a value? When we increase t from 0 to 1, what happens to a? Well, it goes from 0 to 6.4. So it goes up 6.4. Pretty straightforward, right? So when we go from 1 to 2, we increase by 1. What should happen to a? Well, a should also go up by 6.4. 6.4 plus 6.4 does indeed give us 12.8. So it goes up 6.4. We go up one more, just to make sure we're on the right page, make sure we're on the right track, make sure this is a proportional relationship. We go up by one more here. We go from 12.8 to 19.2. You need a calculator real quick. You don't, because it's going up by 6.4. All right. Now, you might think to yourself, Mr. Stevens, you just said 32 over 5 was our slope, and now you're saying 6.4 is our slope. Luckily for us, if we have a calculator nearby, we can see that 32 divided by 5 is indeed 6.4. Give us 6 2/5, which gives us 6.4 as a decimal. All right. So either way, whether we write our slope as 32 over 5, okay, so we can say 32 over 5 equals m, or we can say m is equal to 6.4. It's the same value, again, just in two different forms of the same rational number. 32 over 5 is a fraction, 6.4 as a decimal. I would prefer 32 over 5. That's just me, though. All right. Either way, this is your slope. Your slope is the same thing as your constant of proportionality. It's the same thing as your increase of y as you increase x by 1. all of these things, they're all the same. They all tie together. They're just used in different ways. This equation, this table, and this graph are three different representations of the same situation. It's the same thing mathematically in all three modes. Okay, this, and this are all the same, all representing the same amount. Just like these two are the same, representing the same value in two different modes. So we have to be able to compare from this as a linear equation to a table, and from a table to a graph, and then a graph back to an equation. All of those things we have to be able to compare, specifically in 8th grade, determining which one has a larger slope, things like that. Those are all part of what is required for us to do here in the 8th grade. All right. Hopefully this makes a little bit more sense when you go to 15 and 17 on your assignments. But that's all I got for you today. Adios.